Hi guys, welcome to our channel of Sciences and Mathematics. Today's topic of discussion will be based on basic integration rules, and we're going to see that having defined the concept of an integral in one of our videos, we're going to see that there are some of these or maybe specific rules which are going to be used in trying to find integrals of some symbol, of course, functions, integral functions. So in this case, we're going to apply a few of these rules, and maybe by giving examples so that they can be able to assist us in understanding the concept. So without further ado, thank you and welcome. So as I've said, today we're going to look at the concept of basic integration rules. And this is going to assist us or form a basis for us in trying to solve maybe some of the integral functions, which is of course going to assist us in finding integral or the integral, trying to solve the integral functions of higher order as we go by. So in this case, the last time we talked about the concept of an integral or introduction to integration. In one of our videos, we say that an integral, of course, stems from the fact that we had discussed about the area under a curve. And this came from the methods of fluxions that we had discussed. So generally in our video we had discussed about the concept of or the slight history of where the concept of integration came from. And this was based on the fact that initially there were some challenges in trying to find areas of round curves. So and this one of course was developed over time from the concept of Kepler's planetary motion and the Newtonian concept of trying to find areas under curves, which led to methods of fluxions that we refer to as integral calculus. So in this case, I'm just going to use a statement to try and interpret what an integral is. But in our last discussion, we had given the representation or a integral notation. So I'm going to start from here. We had given an integral notation as the integral of a function fx dx can be given as fx plus c. So in this case, this first part of it is what we had given as the integral function, or the notation for an integral function, whereby we said that the symbol, this elongated symbol, is an elongated form of a symbol for s that basically refers to the concept of sum. So therefore, when we are trying to look at the area under the triangle, that the area under the curve that we had said, maybe from point A to B of a function fx, and we said that we can be able to find the area under the curve by trying to find the sum of the areas of the respective rectangles that are formed by the distance between A and B, whereby we said that the individual distance between these specific rectangles can be given as the sigma x, where sigma x is a small change, and therefore the summation for this sigma x gave us the dx that we are talking about of this specific function. And this change in the y-axis that we talked about, we had given it as the height of the triangles, so the rectangles. So therefore we had said that in finding areas of rectangles is length times width, and we had considered this one to be our width and this one to be our height, and therefore this one gave us the concept of what we are talking about, the integral. So therefore, without revisiting that, maybe I'm going to put a link of the video in the description box. Without revisiting that, we're just going to define an integral which is going to give us a basis for the basic laws of integration. Now, just to do away with this, so this concept that we call an integral can sometimes be referred to as an antiderivative in that specific way. So a function f, that is capital F, is an integral or an antiderivative of a function f if for every x in the domain of f, it follows that the derivative f prime x equals fx. So therefore, in terms of representation, that is how specifically we can be able to define the concept of an integral. And then from this particular statement, therefore, then if f prime x is an integral of fx, then there's a second part of that fraction that we are given for the notation of an integral, and therefore f, this is capital Fx plus c, is an integral of fx, where c represents a constant. So basically, we're going just going to use our specific examples to try and illustrate these specific concepts that we are talking about of an antiderivative and the functions that we have basically tried to give that one. So as we go ahead, this statement is going to make more sense as we're trying to solve our example. So basically, that's one of the explanations in which we can be able to give the concept of an integral, apart from the one that we are given that an integral represents the area under the curve. So there are 4 specific rules, general rules, that we're going to look at in the rules of basic integration rules. And the first one is known as the constant integral rule. Constant integral rule. So for a constant integral rule, we're going to use the notation for the integral notation that we have used. The summation k dx, or the integral k dx, is going to be given as kx plus c. So this is the rule number 1. And then there's a second rule that we're going to use, which is a constant multiple. Constant multiple rule, R represents rule, so constant multiple rule. And this one states that the integral k, so the integral k fx dx is given as k, the integral of fx dx. And then 3, we're going to look at another rule that is known as the sum or difference rule. Now for the sum or difference rule, we're going to see that it's 2 functions which have been added or subtracted. So therefore the integral of fx plus or minus gx is going to be given as the integral of fx dx plus the integral of gx dx. So that's either the summation or the difference between those 2 integrals. They can be given as separate, the sum or the difference of those 2 integrals. And lastly, we're going to have what we call the symbol power rule. So this is number 4. Symbol power rule. And this one states that the integral of x, whenever we're talking about the concept of power, that one implies the exponent. So therefore it's x exponent n dx is going to be given as x, maybe just use this one, x n plus 1 over n plus 1 plus c. So this is a general format for basic integration rules that we're going to encounter in some of our discussions, and they're going to apply in different ways, and of course they imply the concept of exponents that we have tried to talk about, and we're going to see that some of them are going to have negative exponents, so therefore we'll have a specific way in which we are going to represent them. So first we have the constant integral rule, which defines the integral of this specific format. The second, which is a constant multiple rule, of course, we're going to see that the concept of this constant is going to be taken as independent, and then we find the integral of the rest of the part of that integral expression. So the sum of the difference rule is going to be found by finding the integral of those specific parts of the expression. This is dx. So it's going to be found by finding the dependent part and finding a sum of the difference. And the simple power rule, of course, is using the concept of the exponents, and we're going to use that one in order to find. So I'm going to give specific examples for these particular rules that we have discussed in trying to illustrate this one. So suppose we are asked to find the integral of of 2 dx. Now from the constant integral that we are given, that the integral of k dx is equals kx plus c. Therefore this is going to give us a basis for trying to solve this particular integral expression, which is going to give us 2x plus c. So we can just try to see the relationship that existed between the first constant integral rule and the question that we have been given for 1. So that is how we're going to find it. So number 2, suppose we are asked to find the integral of 3x dx. So this stems from the concept of a constant multiple rule that we have talked about. So therefore this is going to be 3 the integral of fx dx, as we talked about, to be the general rule for that. So we are not going to include this. Now this is for the function, therefore it's going to be x dx, and this is going to give us, of course, this is 3x squared over 2. So whenever this addition of this exponent is going to have the same value for the denominator, so it's going to be 3 over 2x squared plus c. That's going to be the answer for that. Now suppose I talked about the concept of a negative exponent, and we're going to see on how this one works. So this is 1 over 3, x cubed dx, and we're asked to find the exponent for that. This one can be written as the integral of x negative 3 dx. So therefore this is going to be the integral of x negative 3. We use the power rule, plus 1 over negative 3 plus 1. So this is going to be plus c. So in that case, this is going to give us the answer for, this is x negative 2 all over negative 2 plus c. This one can be written as 1 over negative 1 over 2x squared plus c. So therefore, a rearrangement of these specific orders is going to come from the concept of negative exponents that we have already discussed in our laws of indices, or powers and indices. Our powers are just a laws of indices. And then we are going to look at another one, maybe that can have a combination of 2. This is the root of x dx. So therefore we're going to write this one, of course, again it's going to be, this is x half dx, and this is going to be x, still an exponent, so it is half plus 1 all over, this is a half plus 1 plus c. So this is going to be x 3 over 2 all over 3 over 2 plus c, which is going to give us 3, this is going to give us 2 over 3 x 3 over 2 plus c. So that is going to be answer for that. And lastly, maybe we can look at a combination that entails the two concepts for the powers and maybe the constant multiple rule. And that is example number 4. So therefore, suppose we are asked to find the integral of a function, which is 3x4 minus 5x squared plus x dx. So this one we just apply the basic rules for exponents that we have talked about, and for the constant, for the, of course, the constant multiple rule that we have already discussed, or the constant integral that we have discussed. So therefore this is going to be 3x4 plus 1 over 4 plus 1 minus 5x2 plus 1 over 2 plus 1 plus x squared over 2 plus c. So this is going to be 3 over 5x raised to power 5 minus, this is 5 over 3 x raised to power 3 plus x over 2 squared plus c. So this basically is going to be in that specific format. And some of these basic integration rules are going to be applied in a way that maybe it's a combination of either rule number 1, 2, 2, 3, all of them, just as we have seen in this expression that is entailing the concept of exponent, or the power rule, and the constant multiple. So in that case, those are some of the basic integration rules that we're going to apply maybe in mathematics or sciences, and some of the questions that may entail the concept of integrals, or maybe where we may be needed to use the concept of integrals. Just have a look at how we have been able to apply the specific rules that we have mentioned in order to find the solutions to those respective problems. So that is it for today, guys. Bye. God bless.